Hi everyone, to continue our journey of the video lectures of sequence and series, this is the part 2, our second episode. In our first episode we had done something about the arithmetic progression, and now it is the term of the geometric progression, or we call it GP. So it is a sequence in which the ratio of any two consecutive terms is same. As for example, A, AR, AR square, etc. Where A is the first term, or is the common ratio, and Tn, that is the nth term of this progression, is A into r to the power n minus 1. It is simply from analogy. It is A means A into r to the power 1 minus 1, the first term. The second term, A into r, meaning A into r to the power 2 minus 1, A r square, is the third term. And this way, from the analogical point of view, it will be Tn equals to A into r to the power n minus 1. Now, invariance of a GP, what does it mean? It means if a GP, like ABC is in GP, then the following are also in GP, like if we change the order ABC, we changing the order CBA, or it is something lambda times ABC, lambda A, lambda B, lambda C, or each term is divided by lambda, A by lambda, B by lambda, C by lambda, where lambda not equals to 0. Or the terms are A to the power n, B to the power n, C to the power n is the exponent where n belongs to the natural number. Or it is reciprocated 1 by A, 1 by B, 1 by C, all will be in GP if ABC is in GP. Next, the sum of the first n terms of a GP. Let A be the first term, or be the common ratio of a GP, and Sn be the sum of the first n terms. Then we have the cases. Case 1, when r not equals to 1, there is a common ratio not equals to 1. Then you see Sn is equal to A plus AR square plus dot dot dot. This way, A into r to the power n minus 2 plus A into r to the power n minus 1, the nth term. Let this equation be 1. And if we multiply both sides with r, then r into Sn is equal to AR. We are shifting one term on the right side. So A becomes AR becomes AR square, and this way, finally it becomes A into r to the power n minus 1, and this term multiplied with A becomes A into r to the power n. Let it be equation number 2. Then if we subtract the equation 2 from the equation 1, then it becomes 1 minus r into Sn is equal to A minus A into r to the power n, take A common. Therefore, this is equal to A whole into 1 minus r to the power n. Or else Sn is equal to A into 1 minus r to the power n by 1 minus r. If you take minus 1 common from both the numerator and the denominator, this will become A into r to the power n minus 1 upon r minus 1. Now when we do it, when r is less than 1, we use this formula. When r is greater than 1, then we use this formula. Now the case 2, when r equals to 1, then Sn becomes, all will be A, because r is 1. Therefore, A plus A plus A plus, this is up to the n terms. So similarly, the same term A has been added for n times, and that equals to n into A. Now, let us take a special case. The sum to infinite terms of a GP when modulus r is less than 1. That is, r is lying within 1 and minus 1. R is less than 1, greater than minus 1. Or r is a proper fraction and r definitely not equals to 0. Then Sn is equal to, we have got the formula A whole into 1 minus r to the power n by 1 minus r. Or that equals to A by 1 minus r minus A into r to the power n upon 1 minus r. Now, as n tends to infinity, r is a proper fraction. As you go on increasing the power of n, so naturally, limit n tends to infinity, r to the power n becomes 0. So in that sense, therefore the s up to infinity means the sum of the terms up to infinite terms, that becomes A upon 1 minus r. when modulus r is less than 1. Take some example, Let you take the example, the sum of 1 plus half plus 1 by 4 plus 1 by 8 and so on and so forth up to infinite terms. So you see the first term is 1 and the common ratio, it is half. So as according to this formula, that will be the sum will be equals to 1 upon 1 minus half, that is it is similarly 2. Easy. And you take this example 1 minus half plus 1 by 4 minus 1 by 8 plus up to infinite terms. So here the first term is once again 1 and the common ratio equals to minus 1 by 2. So that way that sum becomes 2 by 3. Okay. Let us come to the next point. In some cases we will be dealing with this type of problems where 3 numbers are taken to be in GP. We may take them as A by R, A and AR. So if they are given that 4 numbers are in GP, we will be taking as A by R cube, A by R, AR and AR cube. Now let us take the geometric mean. What is mean? Mean means the mean term, If A, X, B are in GP, then X that equals to root over AB is the GM, means the geometric mean of A and B. How it is easy? If X by A, because X by A is equal to B by X, so naturally cross multiply X square is equal to AB and thereupon X becomes equal to root AB. Now if A, X1, X2 up to Xn up to B, the first term is A and the last term is B, and we have introduced n number of GMs into it. So this is lying in GP. Then X1, X2 dot 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 up to Xn are the n geometric means between A and B. Now as B is the, how many terms there are A and B and in between there are n number of terms. Therefore B becomes the n plus 2th term of the GP, and that equals to, according to your formula, A into R to the power n plus 2 minus 1, or that equals to A into R to the power n plus 1, or this way you get R equals to B upon A whole to the power 1 by n plus 1. The exponent becomes 1 by n plus 1. Therefore X1 equals to AR, you just place the value of R. X2 is equal to AR square, you place the value of R. And this way for Xn, it will be B upon R, because Xn multiplied by R, it becomes B. So B equals to, Xn equals to B by R. So that way A into R to the power n plus 1 upon R, or that is A into R to the power n, and because R, so place it there. So R to the power n, A into R to the power n, this will be this. Okay, A into R to the power n, this is it. Okay, so this was the sum of the salient features of the GP we have discussed. Now let us go to the question. The first question I have taken from the IIT entrance exam of 1974. In a set of 4 numbers, the first 3 are in GP and the last 3 are in AP, arithmetic progression. We have already done in your first video, with a common difference of 6. The AP is having a common difference of 6. If the first number is same as the fourth one, then find the 4 numbers. So let us do it now. Let the last 3 numbers in AP be B plus 6 and B plus 12, because the CD is 6, it is given, and the first number be A. So it is also given that the first number is equal to the fourth number. Therefore A is equal to B plus 12, and A, B and B plus 6 are in GP, it is also given. Therefore the square of the middle term B square, that will be A into B plus 6, and this way you just replace it. Okay, B square is equal to B plus 12 into B plus 6. You solve it and you get 18B is equal to minus 72, that is B is equal to minus 4. And as B is equal to minus 4, the first term is equal to minus 4 plus 12, that equals to 8. Hence the 4 numbers will be 8 minus 4, 2 and 8. Now let us take another question. This is also from the IIT joint entrance in 1962. Now if the nth term of a series, what is the series? 1 plus x squared dot 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 up to x to the power minus 1. Nth term is this. Then the sum of the first n terms is, these are the 4 options that is given. These are the 4 options, you have to select one The correct option, you know. This was set in the IITG in 1962. So let us answer it. What is given? Given TR equals to 1 plus X plus, you know, plus dot 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 up to X to the power minus 1. So this is the sum. The sum will be 1 minus X to the power R by 1 minus X. This is the rth term of that. Therefore, the sum of the first n terms of the GP, it will be a sigma, or we call it the summation TR when R equals to 1 to n. That means TR, T1 plus T2 plus T3 up to n terms, okay. So that equals to summation R equals to 1 to n, 1 minus X to the power R by 1 minus X. This I have placed here. So now break it up. Therefore, it is summation R equals to 1 to n, 1 by 1 minus X minus the summation R equals to 1 to n X to the power R by 1 minus X. Now this term has been added for n times, so that will be n by 1 minus X minus here 1 by 1 minus X into the sum of this series, okay, and that equals to X into 1 minus X to the power n, and by 1 minus X that multiplies with this thing, so it becomes 1 minus X square. So summary is n by 1 minus X minus 1 by 1 minus X square whole into X into 1 minus X to the power n. You just solve it, and you get this answer, you know, that which matches with the option C. So option C is the correct answer. Okay, so option C is the correct answer. In our next part of videos continuing on this subject of sequence and series, that is part 3, part 4, etc., we will be discussing with some more questions taken from the IIT entrance exam. And if you like this video, then I request you to subscribe, share and like it. This is all for today. Thank you all.